Hello students, myself Mrs. Bhavna Mukesh Vyas from Pune Institute of Computer Technology will be presenting a topic nanomaterials. During my presentation, I'll be covering the introduction of the nanomaterial, classification of the nanomaterials based on dimensions, structure, properties and applications of few nanomaterials like graphene, carbon nanotubes, quantum dots, and at the last conclusion. So there will be a series of presentations. So I'll start with the topic, I'll start with the content, first content, that is the introduction. So introduction of the nanomaterial. But before before starting the topic, first we should understand what is the course objective of this learning and what will be the course outcome of the learning this topic, nanomaterials. So when as far as course objectives are concerned, it is to understand the structure, properties and applications of nanomaterials, and the course outcomes will be then the student will be able to demonstrate the knowledge of advanced engineering materials for various engineering applications. So let's start with the topic nanomaterials. So first we'll start with the introduction part. When we say nanomaterials, so it is how we can define it. First, let us go for that. Let's see the definition of nanomaterial. According to the ISO, that is International Organization for Standardization, the prefix, that is nano, this one, the prefix nano refers to the size ranging approximately from 1 nanometer to 100 nanometers, and as a comparison, the diameter of carbon atom is about 0.25 nanometer, and the distance between the carbon atom is 0.15 nanometer. So it means that nanomaterials are larger than a single atom size, or even we can say a small group of atoms. So as far as nanomaterial definition is concerned, then we'll define it as a set of substances where at least one dimension is less than approximately 100 nanometers. So if we consider a strand of hair whose diameter is approximately between 60 to 120 micrometer, and if we reduce it by 1 lakh times, then we'll get a 1 nanometer diameter material. So this is what is the what we can say about the definition of the nanomaterial, the scientific definition. But how small it is, how we can feel that, because it is not visible, so how we can feel that. So what are the materials which are natural as well as man-made, which are nanomaterials. So let's see the length scale of this materials. So if we consider an ant, its size is approximately 5 mm. As I told you, the human hair is around 60 to 120 micrometer wide. The dust mite is approximately 200 micrometer. The RBC is then around 7 to 8 micrometer. The DNA, again, its size in nanometer, that is approximately 2 and 2.5 nanometer, and the proteins are of nanometer size. Then even we can say viruses, the identified virus, the smallest identified virus is a parvovirus whose size is approximately around 10 nanometers. So these are the natural nanomaterials of nano size. These are the materials which are of nano size, while these are the materials which are man-made, like fullerene, carbon nano, the newly added allotropes of carbon are the at the nanoscale. So this is what is the scale, micro scale, then lesser than that is the nanoscale. So as far as the nanometer it is concerned, then 1 nanometer is equal to 10 to the power minus 9 meter. So that much small it is. So when a question comes in my mind is, why nanomaterial? What is so special about them? Is it something magic? Yeah, there is a magic. We will go for that magic. But before that magic, let me say that the nanomaterial and then its application as a nanotechnology. So this use of nanotechnology, or we can say the use of nanomaterials for some devices or for some applications, is far from being new. For example, it was used in dyes to impart the color in fibers and fabrics around 2600 BC. And while even in Middle Age churches, the stained glass artisans utilized the nanoscale materials to impart some different colors to the window panes. And more recently, the carbon black was used for the reinforcing the tires. So from since 1910 onwards, the composite, that is rubber and the nanoscale carbon black, are mixed to impart the properties, like to increase the hardness, the strength, abrasion resistance, etc. So these are the various applications the nanomaterials is having, and it's not so new also, but the people were using that, but they were not knowing that these are called as nanomaterials. So this coin, the nanotechnology word, was coined by a person whose name was Richard Feynman, and in his talk at the annual meeting of American Physical Society in 1959, entitled "The Plenty of Room is Available at the Bottom," and that was the from that onwards the nanotechnology word the people started using. And even recently, in 1996, the invention of the carbon nanotube, which was invented by a group of people at the Rice University, got the Nobel Prize in Chemistry for the production of for the invention of the carbon nanotube. Okay, so this is what just an idea I was saying, that even right now we are using the nanomaterial, but it is not like that. In the previous our ancestors were also using, but they were not saying that the name is a nanomaterial. Okay, fine. So if it is there, then what is so special about that? So let's see that. What is the speciality of the nanomaterial? See the magic. Here what we can see is the gold coin particle. Yes. Now this gold coin particle, not particle, sorry, the gold coin is of which color? Yeah, of course, it's yellow color, or we can say it's a gold color, golden color. Fine. But if we reduce the size of this gold to the nanoscale, so we'll have the nanoparticles, the gold. So we can see that if we reduce the size of this gold particles like this, the color is changing. So even optically we can see that it's not yellow color when the gold is at nanoscale. So the gold nanoparticles can impart different colors even whenever it is added to some other materials, like in the window panes. If we use these materials, it will apply, it will show its own color. So, and even the various different applications are there. Even in the pregnancy kit, these gold nanoparticles are present to for the test. So there are so many applications associated with different types of nanoparticles. This is just an example. So here I have shown that the reduction in size will from the bulk gold to the gold nanoparticles. How the color is changing. So obviously, if the color is changing, its properties also changing. So isn't it a magic? We cannot think that the golden color or yellow color gold can become a ruby red, right? Okay, so let's so there are so this, when we say the nanomaterials, the structure of the nanomaterials, let's see that what are nano dimensional structure first. Actually, when one or more dimensions of a solid or a material are reduced significantly, its physiochemical properties will totally get changed, or they will get depart from those of the bulk solid. So with the reduction in size, novel electrical, mechanical, chemical, magnetic and optical properties can be introduced, and the resulting structure is then called a low dimensional structure. And these nanostructures constitute a bridge between molecules and the bulk materials. And suitable control of the properties and the responses of the nanostructures can lead to new devices and technologies. So we can use this nanomaterials to get the novel products for different applications. But before developing these novel products, these are the various examples that I have shown, that various examples wherein the different properties will show. Like for optical properties, the color of gold nanoparticles is different, then the size, the electrical properties, and even when we will go for the studying the materials, we'll go in detail of all this. So let's see that how the lesson we can learn from the nature to develop the novel products from these nanomaterials. So the objective here is to develop the novel product based mimicking the what the nature is showing us, or what the nature we are learning from the nature. Okay, so let's see that now. In here, yeah, the very first example that we'll take is this, the Lotus effect. It's a super hydrophobic surface. All of us we know that. So this is a lotus leaf having some droplets of water on this. So the contact area of this water droplets and the leaf on the leaf is very small. So why? So if we magnify on high, if we keep this leaf under the surface of the under the microscope, the surface will look like this. So it is showing some nanostructure here. You can see that, which doesn't allow the droplet of water to settle on it. So the non-wetted surface we can get on the lotus leaf. So this is what the nature is showing us, and inspiring from this Lotus effect, a German company, BASF, artificially developed super hydrophobic nanostructured coating for self-cleaning paints and spray. Here they have their patents on this, and this is the mimicking of the Lotus effect. And now the next example that I am showing it to you is about the Gecko Effect. Yes, everybody know that the Gecko Effect is having super glue, natural super glue with dual properties like high shear adhesion and normal adhesion, that is low normal adhesion, using van der Waals forces. Similar type, and if we see the structure of the if we study the structure of this Gecko Effect, we can see that the microstructure is having this nanostructured wires. Nano wires are there on its feet. So mimicking this Gecko's Effect by using the carbon nanotubes, one can make a super glue in the form of dry adhesive, and the similar type of project has been done by a group of IIT Kanpur students. Okay, fine, wherein the stiffness of tips can be modified by changing the number of walls in the nanotubes. So this is another example that we can learn from the nature, and then we can mimic the things to develop a new product, novel product. So the steps can be super glue tapes can be, and that too dry adhesive, that is non-chemical tapes, can be manufactured by using these carbon nanotubes. So this is the structure that is shown here in the images. And another example that we can take is a seashell and its brick. So seashell and chalk both are made up of CaCO3, but still seashells has a very high mechanical strength than chalk stick because of its structure. So understanding and mimicking the natural technology can be used to build the materials with high mechanical strength for the usage of different applications. So this is what the examples that we can learn. This is what the examples which are there